It is not something that we can do only for today. We have to do things for tomorrow with proper governance. It's very important in everything. We do things that will secure the whole supply chain. And let me now let Vincent
put in the images for the model to predict. So, because right, every phone that you use have different algorithms and settings and things like that, so it won't be consistent. So what we have done is we even embarked a bit deeper and then built a hardware, okay, that will consistently take the photos and readings and data relating to the gemstone and then feed it to the AI model, which then in turn give inferences and predictions for important informed decisions by the traders, for example. So just in short, there is the optical device. It is a product that I'll show and tell a bit more afterwards. The model, which today we are very much using it. And we will build a very interesting user interface. Okay, we today call him GemGPT. The name can change, but essentially it's a digital gemnologist. Okay, where are we today, and what do we think that we can change? So I think everybody in this room are either a very qualified gemnologist or curious gemnologist. Some of us, in fact, most of us would be getting our on-the-job experience in the trade, all right, acquired over the years, inherited from our fathers, grandfathers, but many are a bit more passionate and then have the qualification for it. But of course, there are a lot of fraudsters as well, who pretend to be gemnologists and make representations that is there to cheat and not misrepresent facts. So the other big challenge in the industry is, of course, to do gemstone assessment, really to do it accurately. As Surya-san just now mentioned, it does rely on analytical tools. All right, they can be very expensive, and then the high level of expertise is required as well. You can see this graph. It really takes a lot of training and experience to be interpreting this. The other issue is lack of industry standard on color, for example. And then today, you see a lot of copy which is printed of your stones, but there is no digital image that is provided to you. So we feel that the owner of the stone should have also a very faithful photo of the stone as well. So these are the general challenges that is faced by the industry today. So we want to introduce something called, just a concept, digital gemnology 2.0, where we think technology will be the enabler. We want to use technology to improve ourselves in way of efficiencies, build transparency, blockchain, just now Surya-san talked about it, and of course create new industry standards as well. All right. Okay, so what is it? In the nutshell, it is really trying to marry two broad subjects, photomicrography and AI. I'll show you some examples of the applications later on, because that is important. I think today we are so exposed to maybe ChatGPT, which was launched about 18 months ago. So today it is very, it's all over the place. So I think it is time as well to be applied in this industry as well. So what we are trying to offer here is to democratize the use of AI. So if the last 10 years, AI is in the realms for Facebook, Google, Microsoft, but I think since ChatGPT came around, it has become AI tool for all of us. So we intend to do the same, okay, whereby the community, the trade in the gem business can also use AI as a tool to help their daily work. So it is really to empower traders to leverage on data, okay, and then to have insightful, evidence-based. Mr. Surya-san mentioned many times about evidence as a way to make informed decisions. So the time is ripe because I think many industries are already at the forefront of leveraging and exploiting AI for their work. I think the gem business is a bit behind, but that provides the opportunity, right, for all of us. Because today, it is very cheap. Computing power, you can just tap onto the cloud and use on demand and so on. So it allows innovative companies like us to very quickly create products to offer to the industry. And then there's a lot of data. As I say, we are 152 years old. There's a lot of data that we can use and leverage on. The lens and camera cost has become quite low because of our phones. I think everybody in this room owns a phone. So that's only because the lenses and the cameras are very, very cheap now. So we want to leverage on that as well. And more importantly, today AI on an open source basis has become very, very accurate, very performant, and has become mainstream. Okay? So the congregation of these the factors has allowed us to. Okay. So I want to announce, I mean, this is the first time we are really telling the public, this is the product that we have come out with. This is called the Chroma. We have two versions of it. One is called the Krista, just different configurations and features. It's not too big. It's about the size of a shoebox, right? And about 3 kg. More importantly, it's got very, very advanced camera system in there, about 8 megapixel. And it is very color faithful. I think everybody wants a photo that clearly represents the real stone. All right, so we make sure and then do a lot of experimentation and so on to control, particularly the correlated color temperature and the color rendering index to be as good as possible. So we calibrate our screen, for example, and so on and so forth. So there is a 7-inch screen, touch screen for you to interact with the stone when it's being photographed. Of course, we have other ports as well. If you like to see in a bigger screen, there are ports in there, and then wireless as well. So we are really, this product is putting in your hands, okay, 4 things. Okay, it's a camera, it's a microscope, right? It's a colorimeter. Colorimeter is measure color, right? And it's a computer. So it actually runs on Windows, so just like a computer. But more importantly is we are making it intelligent as well. So putting in AI into it, not so much into it, but more accessing the cloud, all right, to give you inferences and predictions based on data that we have already trained. So 4-in-1, 4 plus AI. Okay, so some photos of the color faithful. This is a very important thing, as I say. It's a very color faithful. I don't know whether this projector is showing it properly or not. I think you probably know in color management, all your equipments have to be also color calibrated. So we take pains in that. So this is very color faithful. The owner of it, after taking it, has a dot TIFF, not compressed, or BMP. So you own not just a stone, but a digital image as well. You know, you can do wonderful things with that. And then we do even more value add. I will show you afterward that we actually help using AI to grade the color. Today we rely on of course, human beings who are very well trained, the gemnologists, to be able to grade that. You don't see a good photo of this now, but I'll have an exploded view of it. This is the stone in immersion liquid. So that allows us to take the inclusions of the stone. So with this very clearly visible. So I think the traders would, of course, love it, but I think it will also benefit the cutters if we can get this rough as well to be seen in as far as possible, the inclusions. So we just patented it about 3 weeks ago. Hence, that's why we are a bit more open now, you know, to be telling everybody else. But we feel that this is something that we can work on. This is our first series, and there will be more improvements to come. Okay, sorry, just some examples of the. I'm sorry. Just some examples of the outputs from this. As I say, color faithfulness is a very important R&D that we work on, okay, to get the gemnologists to ensure that it's really the same color as what is seen in the physical sense. Today we have the loading of the sample in the tweezer, right, when we put it inside the analyzer. This is the one that is without the liquid, and this is with the liquid. So in the exploded view, you can actually see already the inclusions in there very clearly. And as I say again, you own the photo, so you can get and do a lot of informed decisions based on this as well. Okay, another photo of it. The inclusion is here in this sense. Unfortunately, you don't see too well, but of course, you can actually explode it as well because this is taken on a very high res 8 megapixel 2840 pixels representing this photo. All right. Now, another one, we of course see this, the real one, but of course our AI engineer can do different algorithms to it as well. Okay, when you go to machine learning, sometimes the machine likes it to be not black and white, but grayscale, to be a bit more discerning. Another one, stone, where we can just turn it to different things, different colors, different grayscale level, to improve the contrast and dynamic range and accuracy and things like that. So these are all done at a pixel by pixel level. So the analysis is very, very accurate. Okay. All right. This is one of the main value proposition we have as well. We want to still improve on this. Just now you saw it in the tweezer, right? So we want to improve on this as well, so that you can see the full stone. So this is an emerald. We tested on it because the emerald is very included. And the visualization, as I said, this is the video that you own if you have this device. So you can see inclusions, growth patterns, fracture, all the things that it will be useful for you to make a judgment of the quality of the stone. So of course we're going to improve it along the way. I think a few factors. I mean, like the tweezer, the handler, illumination, and other activities as well that we can work on. So two others. These two are sapphires. Right? You can very clearly rotate it and then see the 3D, the growth of the inclusion. Okay, that's one example. No AI, just a video. But I thought I want to just elaborate a bit more on the color classification, because this is really exciting. Mr. Sunil talked about a friend that we knew from Germany. When I kind of showed the concept to him, then we said we're going to build a AI-driven color classifier. Then he said, oh, that's going to be good. I said, why? He says, because I want to retire and my son is taking over the business. But I still have to go along with my son every time for buying and selling. I said, yeah, why? He says, my son, who is in the gem trade, is colorblind. So you can imagine some of the challenges. Fine. So hopefully, if our tools work, he doesn't have to. That's Mr. Alex, Mr. Sunil, won't have to go along. So let me try to explain a bit about how we want to do it, because AI is not about just getting results. AI has allowed us to actually understand meaning of data, meaning of this and that. So firstly, we have about 60 over 1,000 stones as a data start. So this is a 3-dimensional distribution of every stone, the 60 over 1,000 stones in there. But how do we plot this 3-dimensional? We are very familiar with red, green, blue, RGB. Every color has three values to it, and we can plot it there. But we have done a lot of researching, and our color scientist says that I think the best one is going to be LAB space. So give me a moment to try to describe why we use LAB space. So CIE is the World Global Organization to control color and illumination. So they have many color spaces. So we have to choose that because LAB, which is represented here, any color can be within this sphere, so-called, if you split it into LAB. So LAB is just, this vertical axis is just a grayness. This is green, red, and then you see yellow, blue as well. But anyway, you can split it into that. But what LAB can do is, I think we are very familiar with physical distance, okay? Me relative to you is about 5 meters, and then me relative to that is, we can describe distances. But if you split it into LAB, you can then measure color distance. Color distance. So that is important because if we have a standard that this is the space where Paparaja sits, all right? Then we bring a sample, LAB, we say here, we can even calculate they call it the delta E. Okay? This delta E has a very unique name as well, just to give you why we chose E. E, if some of you understand German, it actually stands for Empfindung. Empfindung in German is sensation. So it is very related to how human vision see color and the distance and the tolerances and stuff like that. So now we have a method, scientific method created by षणyAI to measure color distances. So going back to my slide before, so what we did then, we find these are about 30 different colors. The cornflower blue, royal blue, this blue, and blah, blah, blah. Paparaja pink, orange, paparaja orange, pink, blah, blah, blah. So for each of them, we find the centroid, the middle of each of these color. And then we represent it. You can see the dots. Every dot is a color. In the LAB space, you cannot see because the print is too small as far as the label is concerned. So what we have invented, and hopefully to be adopted worldwide, is a reference standard, all right? Which in future, if we use the chroma or the crystal or something similar in the device, follow the standard, pump in to the machine learning thing, and then he will just go to whichever is the closest. I'm that color, all right? But of course, within tolerance as well. So you need to measure the delta E. The world has to agree on acceptable color tolerance as well. So this is what AI can do, all right? It is scientific. It is something that people can understand as well. Today, colorimeter is very, very, very common to measure plastic, fabric, paper, and solid colors. But nobody has invented yet something for our gemstone to measure color objectively. So no more subjectivity, no more color blindness because they won't tell you they are color blind. We have an equipment now that can at least give you some objectivity in color measurement. So I thought I want to elaborate a bit more on the color thing and some of the results. Okay, this is really coming out from our AI model. I'll go to this big one first, how to interpret it. We have, through our very experienced gemnologists, they already label, original label is already blue. So this is all labeled blue. Don't worry too much about this additional information. But P1, P2, just to give you an idea again, you must understand it's probability 1 and probability 2. So we are telling the computer, hey, what do you predict it as? Okay? So this has predicted it to be blue. He even tells you at 44% confidence. And probability 2 is blue cornflower. We code it as CF, cornflower. The computer is 43% confident. So obviously then the customer sees as, okay, this is blue because P1 would be the one that is going to be thrown out to the customer, right? So he got this accurately, all right? So we do the whole blue population that we have, okay? These are the wrong ones, these are the wrong ones, these are the correct prediction, all right? Because, it's too small for me to read here, but it will always pick up the P1s, all right? But it will tell you the P2. If you want the P3, you can tell it as well. We needed this information because it doesn't end here. We will pass it on to the gemnologist. Hey, gemnologist, is this correct? Is this wrong? You know, can you improve and things like that? So it can only get better in terms of percentage. Overall, we have the 30 colors. Our percentages were very high, even at the initial start. It's about in excess of 93%. Okay, so it is very promising. I think, as I say, it is not new, but it is new in the sense that we have now the data, the initiatives to work on this. So this is pink, orange, paparaja. That's how we label it. Same thing, wrong, wrong. But these are the correct ones. All right. Always picking up on the higher probability one. All right. Some are very obvious. Sometimes they have even a percentage of 70% confidence in P1. Okay. So we talked about the video just now. That's one benefit, but no AI. Color has AI. Okay. This is even more profound. Because here, with the video here, not the video, the inclusion photo, right? I will explode it afterwards. What we are trying to do is, in fact, maybe I'll explode it now. What our gemnologists are doing, right, is after we take this photo, he is boxing up, and giving it a label. There are about 30 labels of inclusion. I didn't create it, but the gemnologists are actually always looking for this because it gives diagnosis and clue whether it's treated or not, or maybe even it's synthetic. So we didn't invent this. Facebook invented it. Today you put a photo of your group on the Facebook, straight away a boundary box comes out and it's Vincent and blah, 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 blah. So if it can be done for faces, right, this is no big deal. I mean, only you need to teach him. So we need a lot of data. And as I say, we took the pains in the last month to label them. You cannot see it here as well, but basically they've got a lot of boundary boxes labeled to any of these and so on and so forth. So in future, this will be a good tool. We're not going to replace Gem Labs. No way. No way we're going to replace Gem Labs. But it's a productivity tool to help us process more. Okay? The gemnologist will still have to come out before he signs on the certificate. He still has to confirm all this. But his productivity has improved. And of course, less trained gemnologists come in can also learn a lot quicker as well, in as far as this is concerned. But if this tool is also given to you guys, you have it in your hands, of course it's going to be also very useful. But if you need a certificate for global recognition, please go to a Gem Lab. We are not going to issue certificates here, okay? All right, let's be clear. But you can see what we are doing here. I mean, the red ones, automatically if it's detected, we will say that it's treated. Okay? There's no two-way about it. Okay, and one final one, okay, in terms of the benefits, Mr. Freya just now mentioned a lot about origin determination by way of measurement, like using the EDXRF, but also blockchain. So, but before we can have the blockchain, and we really need to tag the stone, right? Because if not, you cannot turn it into a NFT, we call it a non-fungible token. Once you have the NFT and it's tagged, then you can trace it. It becomes, you don't need traders anymore, as in middlemen and things like that. I can buy the stone directly. So what we are trying to do now is to give the fingerprint of the stone. So we will scan it, okay, give it based on the inclusion today. But actually AI is not just looking at the inclusion, but the inclusion is very, very immutable and cannot change unless you cut it and so on. But it will measure a lot of other things as well. So we want to create internally we call it Eugene, but Eugene means it's a unique, unique gemstone ID number. All right? And we will create a passport for it. Of course, it's in the database. So every time the stone once is in the database, next time the stone is again scanned under the same conditions, it will verify whether it's the same stone or not. So that gives really the opportunity for blockchain. Okay, Furia-san, as I say, mentioned it. And I think Mr. Sunil mentioned it as well just now. Ultimately, if you have blockchain, you have unique passports and things like that, it will really, through smart contracts, blockchain has smart contracts, which you don't need lawyers and human beings. Sorry, we have a panel of lawyers here, but blockchain allow really a very transparent way to reward the creator and the miner. Because you can build in the blockchain, you can say 0.00% of the transaction price will go to the e-wallet of the miner, of the creator. So that's anyway in the concept today. If you create a cartoon and an art, right, you can actually NFT it. And if that card is so popular and people actually buy and buy and buy, actually 0.00% or whatever actually comes back to him. So you can see how powerful and profound this technology can become. And to incentivize the people who really put their lives and sweat into getting the stone out of the earth. So I won't talk too much about the NFT or the blockchain side. I think Furia-san covered a lot of the benefits.
The emitted X-ray is unique to each element. When we measure the emitted X-ray fluorescence, we can know what elements are included. This is a mechanism of EDX. Because it is a kind of fluorescence, it doesn't damage the stone. And also it can measure many kind of elements at once. So this is a very suitable for the gem testing. And what can EDX tell us? EDX helped the gem testing laboratory for the detection of first origin determination As we see before, there is a big difference in a trace element. So it helps us for the origin determination a lot. And not only that, it helps us for checking the natural or synthetic. The natural stone has a lot of contamination in it, but synthetic stone is a very pure crystal. The origin report is important because the price depends on the origin too. And the end user can know the origin only from the report. The report covers the all disclosure requirement too. But the unsubstantiated report without evidence are not accepted.